In today's video, we're going to solve quadratic equations by taking square roots. So we'll do problems like the one in red after I explain the simple ones that are in black below. So there's a bunch of different ways to solve quadratics. This method of doing it by taking square roots is one that you should use if you see equations like this where there is no linear term, right? So there's the x squared, but there is no x or x with a coefficient. So that would be your hint that an easy way to solve it might be by taking the square root. So let me show you what I mean by this. In this equation here, a squared equals 81. The same way that you would solve a regular equation by taking the inverse operation, we're going to do that same thing here. So the inverse operation of squaring something is to take the square root of it. So I'm going to take the square root of both sides. And the square root of a squared will leave me with a. Now on the right side, I have to be careful. What's the square root of 81? If you're saying 9, great, but that's only part of the answer. What's the other square root of 81? What other number multiplied by itself will give you 81. If you said negative 9, very good. Negative 9 times negative 9 is 81, and 9 times 9 is 81. So our answer here is 9 or negative 9, and the way we write that is a plus minus symbol. So my answer is positive or negative 9 for this simple equation. So in this case, same thing. You're still trying to get a by itself, or x, sorry, in this case, x by itself. So we're gonna do inverse operations. And just like in a two-step equation where you would get rid of addition or subtraction first, it's gonna be easier here to get rid of addition or subtraction first. So let's remove that minus 49 by doing the inverse. So we're gonna do plus 49 on both sides of this equation. That's gonna leave me with x squared equals 49. And now I have an equation that looks exactly like the ones that we just did. The only inverse operation left to do to get this x by itself is take the square root. And now I just have to remember that the square root of 49 is not only 7, but it's also negative 7. So my answer is going to be written as positive or negative 7. All right, so these are my two roots. So when I think about this to make a connection with a graph, this is going to be a parabola that's going to have roots at 7 and negative 7. Okay, it's going to be a parabola that has zeros at those 2 points. Those are my two solutions. All right, now we have 3x squared minus 3 equals 9. So again, same thing. I'm trying to get that variable by itself. So think about a simple two-step equation. What would you get rid of first here? I'm going to go plus 3 on both sides to get rid of that minus 3, that constant, right? So that's going to make me bring down the 3x squared. These will cancel out because they equal 0, and 0 added to anything is that thing. And on the right side, I'll have 12. I continue solving. I'm not going to take the square root yet because I have a coefficient of x squared. So I want to get rid of that coefficient first. So that 3 is being multiplied by the x squared. So I'm going to do the inverse operation, which is to divide by 3 on both sides. 3 divided by 3 is 1, so that's going to leave me with x squared equals 4. Now, this is the point. Once you come down to the variable squared equals a number, that's the point at which you take the square root, okay? So x squared is 4. I'm going to square root both sides to give me x equals positive or negative 2, so that this parabola will have zeros or x-intercepts at 2 and negative 2.